I'm good to go. All right. Live from Earth, it's Space Radio. This is Paul Sutter, and coming up, we're talking about figuring out the dark matter mystery, or maybe not. And also, if I have time, we'll be talking more about that interstellar interloper Oumuamua, who just won't stay boring, just keeps getting more and more interesting. And of course, taking listener questions about all things in the universe, because that's what this show is about. We record every Thursday at 4 p.m. Eastern, so call 888-581-0708 to join the conversation. And in today's Blue Shift, I'll be talking about an amazing collaboration with the wonderful writer Ethan Siegel and an Instagram giveaway. How cool is that? But first, the news. Hello, space fans. Welcome to Space Radio. I'm Paul Sutter, astrophysicist at Ohio State, chief scientist at COSI, and for the next half hour, your agent of the stars. We've got an exciting show for you today on Space Radio, where we talk about all things space, astronomy, astrophysics, rocketry, science, and society. If it's above the Earth's atmosphere or even in it, it's in this show's universe. This show lives on listener questions. We record every Thursday at 4 p.m. Eastern here in Studio A of WCBE Radio Columbus, so call 888-581-0708. Light it up. Get those calls in and we'll have a chat. You can also follow along on our live streams on YouTube, Facebook, and Twitch. If you don't know what Twitch is, ask your kids. Go to spaceradioshow.com for the links. We'll take questions that you send there too. You can also follow me directly on Twitter, Facebook, and Instagram. My name is Paul Matt Sutter. Seriously, folks, I've only prepped 10 minutes of show material tops, so get those calls in. Before I started taking calls today, I did want to give some shout outs to followers on the live stream. There are people calling in from St. Louis, from Columbus. There are people from London, from Wales, from Scotland, the British Isles in force today on the live streams. How cool is that? And also the Netherlands. Hello, Arnold. I see you from the Netherlands. So many cool people following along on the live streams. You too can follow along on those live streams. You can chat. You can make jokes or wisecracks. You can also ask serious science questions, and I will answer them on the air. Now, the first bit of news that I had that crossed my desk, it was something that came up just last night, just this morning before we started recording, was the news, man. I mean, I love it when journalists, when reporters really take a topic and really love to dig in and spread it wide and get the word out there, because, you know, science is for sharing, and it's important to share what we find out about in the universe with the general public. I don't quite like it when they get a little bit exaggerated. We'll use a friendly word, exaggerated. When they take a topic and they go to extremes where it doesn't really represent that topic anymore. And in this case, I'm talking about the mystery of dark matter. If you're not familiar with dark matter is what most of the matter in the universe is made of. It is not made of protons and neutrons and things that interact with light. We've known about dark matter for decades. It's around 85% of the matter in the universe simply doesn't interact with light. A better name might be invisible matter, but I'm not in charge of naming things, so we're stuck with dark matter. And we've known about it through its gravitational effects. We see it in galaxies, we see it in even larger structures, but we don't know what it's made of. That is the big puzzle. We know it's out there, but we're not exactly sure what it's made of. So we're constantly working on it. We're trying to figure it out. And there have been some new results analyzing some, of all things, X-ray data of galaxy clusters, of huge clusters of galaxies. These are the most massive structures in our universe. The results are interesting. They point to a possible hint of a slight, maybe perhaps, detection of dark matter. It turns out in some models of dark matter, remember, we don't know exactly what's going on with dark matter. In some models, dark matter can interact with itself. The little particles can rub up against each other and they will emit some X-rays of a particular frequency. We may or may not have seen those X-rays in some detections over the past few years. The debate rages because this is a kind of a hard topic, or this is kind of a hard thing to study. But you would think that we've totally figured it out based on the latest headlines. You think we've totally 100% solved it, when it turns out it's just a little piece. We're not quite there yet. So please, I want you to read the articles. I want you to read the sources. I want you to be as excited about the universe as I am. Take the headlines with a grain of salt. And even if the researcher or the scientist themselves says, oh yeah, we've totally figured it out. This is totally revolutionary. In fact, I've already bought my plane ticket to Stockholm to go collect my Nobel Prize. Take that with a grain of salt too, because us scientists, we're trying to get our jobs, we're trying to get our grant money, we're trying to promote ourselves, just like everybody else in the world, looking out for number one. Always look at results skeptically. I mean, that is the heart of science, right? Anyway, that's the latest and greatest when it comes to space. Remember to call 888-581-0708 to join the show. I'm Paul Sutter, and this is Space Radio. Let's have a conversation. An interesting question came up on the YouTube live stream, actually before the show even aired. We do a little countdown so people can collect. And Astro B asked this question before the show even started. I love the early bird feeling you got there, Astro B, really jumping the gun. And I applaud your enthusiasm. And you've got a question about galaxy clusters and superclusters and this thing that you may have heard of called the Great Attractor. And then there's also this dark energy, which is like ripping apart space. Like, what's going on? What is this picture happening at the very largest scales in our universe? And one of the most amazing things here is that it's only in the past few decades where we've started to do these really deep surveys of galaxies outside the Milky Way, of really painting the map, the structure of the universe at the very largest scales. I'm talking, when I say largest, let's make it clear here, I'm talking billions of light years. That is Sagan B, that is billion with a B. I'm talking big stuff here, okay? Not nearby, not neighboring galaxies, way far out south. This is the grand structure of the universe that we're talking about here. And we've been able to analyze, we've been able to see where these galaxies are and where they're going, what their velocities are, where their speeds are, what directions they're heading in. And we've been able to figure out, one, that the Andromeda Galaxy, our nearest neighbor, is on a head-on collision with the Milky Way. We will collide in about 5 billion years, plus or minus a few hundred million. We will crash into that galaxy. It will be a horrible, horrible mess. It'll also be kind of pretty. We're moving towards the Andromeda Galaxy. Us and the Andromeda Galaxy together are also moving in a different direction. So we're colliding, but we're also sliding, if you can imagine that. And we are sliding in the direction of what we call the Norma Cluster. The Norma Cluster is a massive cluster of galaxies already home to over 1,000 galaxies. It's a truly massive object. We live on the distant outskirts, so we live in the suburbs, or even the exurbs. We're pretty far out from the Norma Cluster. And this motion of the galaxies was set billions of years ago. These galaxies, our Andromeda Galaxy, the Milky Way, have been moving for billions of years. They're very, very fast, but space is very, very large too. So on cosmological time scales, this seems like it's super slow motion. So we have structures forming in our universe. In our universe, small things build together to make big things. So you start with small things smaller than galaxies. They glued together a long time ago to give us galaxies. Now galaxies are gluing together to make what we call groups, and even bigger things like clusters, and even bigger things like superclusters. But acting in opposition to that structure formation, that process that's been happening for billions of years in our universe, is dark energy. Now, dark energy, like dark matter, we don't fully understand what dark energy is. In fact, we barely understand what dark energy is, but we do know it's there. Dark energy is the name we give to the accelerated expansion of the universe. The universe is getting bigger and bigger. We've known that for 100 years. Congratulations, we live in an expanding universe. The universe is also accelerating in its expansion, and that shuts off structural formation. That means our Milky Way galaxy will never reach the normal cluster. We will never congeal into that cluster. We will be ripped apart. And that is just the fate. That's just how life is in the universe. We don't fully understand it. It's only been a couple decades now that we've understood, even known about dark energy. So we're still trying to wrap our cosmological heads around it. That is a great question, Astro B, on the live stream. Don't forget, you can call 888-581-0708 to join the conversation. And like I said, there's a YouTube live stream, there's a Facebook live stream, and there is a Twitch live stream. Go to spaceradioshow.com for all the links. Now, before we take a break, I've got a giveaway. I have in my hot little hands right now This Year in Space 2018 desk calendar. If you're on the live stream, I'm holding it up to the camera right now. Isn't that gorgeous? This is filled with pages upon pages of amazing images for inspiration and contemplation. This can be yours. Super easy, at no cost to you except a little bit of your time. Go to Instagram. Follow me on Instagram. My name is Paul Matt Sutter, PaulMattsUtter. Go on Instagram. Look for this picture. Look for the picture where I'm holding the calendar and like that post. So like my page on Instagram, like the post, and then 11 p.m. on January 2nd, I will pick a random winner to get this. I will ship it anywhere. I will ship it anywhere in the world. I promise you. Go to Instagram.com/PaulMattSutter, like my page, look for this post with the calendar. It's pretty obvious. It'll stand out. Like that post too, and that's how you get your name in the drawing. Isn't that cool? Yes, it was a rhetorical question. Of course it's cool. Also, don't forget, this show is brought to you by you. Go to patreon.com/PMSutter to learn how you can keep this show going. Live streamers, if you're watching this video, go to Instagram right now. Like, just take that 15 seconds. Go to Instagram, like my page, like that post, and it's all yours. Remember, this is first dibs because this won't air for another week. So you get first dibs, even though it's going to be random. Welcome back, everyone. I'm Paul Sutter, and this is Space Radio. We've got another question popping up on the live stream. Lots of questions on the live stream. Super active today. Really, really fun to interact with all of you. There's a question. I spoke about dark matter and how we don't fully understand dark matter, and we're still trying to puzzle it out. And Jonathan H. on the live stream asked if there are any dark matter galaxies. Check this out. You want your mind blown? This is exactly why you listen to Space Radio or you watch Space Radio. This is your weekly astrotherapy session where you can have your mind sufficiently blown. I see Greg, the producer, laying back in the production booth. He's ready. He is ready to have his mind blown. Are you ready to have your mind blown? Here we go. Every galaxy is a dark matter galaxy. Boom. Do you like that? You like that? That's why I love this show. Every galaxy is a dark matter galaxy. Based on our best understanding of dark matter, which again, we don't fully understand it, but we got a pretty good handle on its properties, you are swimming in dark matter right now. There are countless dark matter particles, subatomic particles, swimming, flooding the room you're sitting in. But dark matter doesn't interact with light. It doesn't interact with electricity or magnetism. So it doesn't touch us. It's just there, flowing through us. We can only detect dark matter through its gravity, through its gravitational interactions. And the only way to do that is to look at the very biggest scales, to look at the way stars move inside of galaxies, to look at the way light bends around a massive object like a galaxy cluster. This is the only way we can have clues on the existence of dark matter, but we know it's there. And our best model says It is a subatomic particle that fills up galaxies. So our galaxy, the Milky Way galaxy, with its hundreds of billions of stars and its dust lanes and its nebula and its core and all that, is embedded in a far larger object that we call the halo. The dark matter halo surrounds the galaxy. Our galaxy is just like a tiny little point of light compared to this massive halo. And then you look out in the larger universe, you see distant galaxies like our neighbor Andromeda or even farther objects. Every single galaxy is embedded in its own halo of dark matter, a massive sphere of dark matter. Where the dark matter collects, where it's most massive, where it's most concentrated, that's where the normal matter collects. That's where the hydrogen and the helium collects, and where it can collect enough to ignite nuclear fusion and light up, and that's how we see it. The galaxies are like the tip of the iceberg. They're the lighthouse on a distant shore. There are signals. They are our tracers of the deeper, invisible structure in our universe. And we know that structure is there because we understand gravity, how gravity works, and we can see it operating. So we know that there's dark matter there. We can only see a tiny portion of the matter in the universe because it turns out, by the rules of the universe, who picked it, not me, that only a small portion of the matter in our universe glows. Not all the matter in our universe is all hot and glowy. Most of it's dark, most of it's invisible. So every galaxy is a dark matter galaxy. There are small galaxies, small structures. We'll call them structures. There are small structures that are almost purely dark matter that haven't collected enough normal matter to ignite star formation, or not enough stars that we can see it from sufficient distance, like sitting inside our Milky Way galaxy. And so there are structures out there, we believe, that are too small to really ignite and give us a tracer, give us a hint of light, and are just blobs of dark matter floating around. So yes, we suspect there are pure dark matter galaxies, and it turns out every galaxy is at least mostly dark matter. Excellent question, Jonathan H. And remember, you can call up if you want. I realize some of you are at work and are incapable of calling up, for fear of losing your job or whatever, but it'd be worth it. It'd be worth it for complete knowledge of time and space. But you can call 888-581-0708 to join the conversation. And don't forget, I do have the Instagram giveaway going on. Go to instagram.com/PaulMattSutter. That's PaulMattSutter. I know it's a bunch of letters, but I believe you have the capacity to do it. Like my page and like the post where I'm holding up the calendar and I'm making a goofy face. If you do that, then 11 p.m. on January 2nd, I will do a drawing, and you could get that amazing space-like calendar. I was going to say spacey calendar, but then you might think it has something to do with Kevin Spacey. It's not Kevin Spacey, it's outer spacey. It's an outer spacey calendar. Now, there is this other bit of news that crossed my desk that was pretty fun. You know about this interstellar interloper, right? This rock from who knows where, but definitely not the solar system, that came slamming through our solar system. Maximum speed, I think, of 130,000 miles per hour. That is a large number. That's pretty fast, way faster than anything else in the solar system. Came screaming through. We kind of sort of accidentally spotted it. We were actually doing something else, and we're like, hey, what's that? Turns out it's a rock from another solar system. At first, we thought it was a comet. Then we thought it was an asteroid. Then we realized it's an asteroid from another solar system. Now it's kind of weird. It's still not a spaceship. I'm not going down that road. It's not a spaceship. It's still just a rock, but we're interested in what kind of rock it is. Turns out it's a very interesting rock. It has lots of gunk on the surface. It has a lot of gunk on the surface because we suspect... Well, we know it has a lot of gunk on the surface, but we suspect it through its journey through interstellar space. It collected a lot of hydrogen compounds and ices and a dusting of carbon. And then it was blasted with radiation from any nearby stars as a part of its journey, and that turned that dusting on the surface into gunk. We don't think the gunk is very thick, just a few centimeters or a few inches thick, but for an interstellar object, that's a pretty decent amount of gunk, I'd say. I don't know, it's not like we have a baseline here. And it looks a lot like the icy bodies in the outer parts of the solar system, where, say, the comets come from. So is this interstellar interloper known as Oumuamua? Is it a comet? Maybe. Is it an asteroid? Also maybe. It's kind of hard to tell, folks, which is the exciting part. This is unprecedented. This is unprecedented. I thought I was going to have a different word other than unprecedented, but that's it. It's just unprecedented. We've never seen something like this before. We've never encountered a rock from outside the solar system. We've encountered dust grains from outside the solar system, but we've never encountered a rock this close. It's a shame we couldn't grab it, but by the time we spotted it, it was already flying out. It's like already past the orbit of Mars. It's going 130,000 miles per hour. We're not catching up with it, folks. Maybe next time we'll be able to catch it and dig a little, poke around, take a sample back, taste it. Maybe. I wonder what it tastes like. Now that's a good question. That is. I'm asking the important questions here on Space Radio. Thank you so much for all the amazing chats on the live streams, on Facebook, on YouTube. If I didn't get you a shout out, I'm sorry. All right, because there's a bunch of you. But I really appreciate you trying. Budapest, Hungary, calling or watching live on the YouTube. How awesome is that? And you can join those live streams and join that community where basically all of you just make fun of me and chat with yourselves. But I'm cool with that. I'm down with that because it's all about community building here on Space Radio. Now, we're almost out of time today, but before we go, it's time for the Blue Shift. Live streamers, I love you. I love all of you. I'm Paul Sutter, and you're listening to Space Radio, and this is the Blue Shift, my opportunity to get a little bit closer to you. And I don't want to turn the entire episode into a plug. I know of the Instagram giveaway with the amazing Spacelight calendar. Go to Instagram.com/PaulMattSutter or open up your little Instagram-y appy thing and just type in my name, Paul Matt Sutter, and there'll be instructions there for where you could win this calendar. It's free. It's free. I'll even pay the postage. I don't care. I'll do it for you. But I also did a collaboration. I did a collaboration with an amazing science communicator named Ethan Siegel. Ethan Siegel, he's an astrophysicist, and I've never met him before, but he actually met one of my bosses in a bar. That was a very interesting and intriguing story for another day. But Ethan Siegel, he writes a blog called Starts with the Bang, referring to the Big Bang, the universe. And Ethan writes like a machine. He writes so much stuff. He has a couple books out, a book called Treknology, all about the science behind Star Trek, which is pretty awesome. He has another book out of the title escapes me, but you should look it up. Look his name up, Ethan Siegel, on Amazon. Go buy some of his books. He's a really cool guy. I brought him onto my YouTube show, Ask a Spaceman. And we talked about the first stars to appear in the universe. And this is a relatively new frontier in cosmology, in astronomy, in astrophysics. There was a time long ago, 13.8 billion years ago, when there were no stars. There weren't stars, there weren't galaxies, there weren't clusters, ain't none of that, just a bunch of gas hanging around. And it took some time for the gas to clump together, meet each other, and ignite nuclear fusion, and for those first stars to be born. What did those first stars look like? How big were they? How many of them were there? How energetic were they? We don't know. We don't know. It's a new thing. Again, a new thing. We are building the instruments to figure it out. The James Webb Space Telescope is going to figure it out. We have some advanced radio arrays in crazy remote places like the Karoo Desert of South Africa that are going to figure it out. Over the next 10 years or so, we are going hunting. We are going to hunting for the first stars in the universe. And if you go to my YouTube channel, youtube.com/Paul M. Sutter. I know everything else is Paul Matt Sutter, but YouTube is YouTube, and it's Paul M. Sutter. There's a video there. Look up the collab with Ethan Siegel about the first stars. He does like 95% of the talking. So if you're sick of my voice, go to that YouTube channel and you get to listen to Eagle. He's a wonderful presenter. He has a gigantic beard. Now you're intrigued. You weren't going to do it, but now you're intrigued, and you're going to go check out Ethan Siegel talking my YouTube channel. He also wrote an article on his blog. Starts with a bang. Do a Google search for that and figure it out. Tons of fun. And unfortunately, this broadcast is almost done. Thank you for joining me on this voyage of space radio. Once again, I'm Paul Sutter, and this show is brought to you by the Ohio State University Department of Astronomy. Learn more at astronomy.osu.edu. It's also brought to you by you. Go to patreon.com/pmsutter, and you can keep this show on the air. Thanks to Greg Moebius for producing, Dan Michalko for being awesome, and all the fine crew at WCBE Radio for making this show possible. We record every Thursday at 4 p.m. Eastern. Call 888-581-0708 to join me on the air. Also, catch the Facebook, YouTube, and Twitch live streams. Go to spaceradioshow.com for the links. Follow me on Facebook, Twitter, and Instagram. My name is @PaulMattSutter. And go to Instagram, Paul Matt Sutter, and win this amazing calendar. I can't believe it. I kind of want to keep it, so maybe none of you are going to win. All right? We'll figure... No, I promise. I lied. One of you is going to win, I promise. And of course, thanks for listening. See you next week. And remember, science is for sharing. End of transmission. Now, live streamers, hang on. We are not done. We recorded the normal broadcast. Now, my good buddy, Johnny DiLoretto, is going to come in, and we're going to record a special half hour of year in review. We're going to review the top stories this year. So just hang on. We're going to take like a 5-minute break or so to get set up for the new segments. But just hang on. Sorry, I got distracted by a YouTube comment. Click like before it has... I get it. I get the joke on YouTube. So there's this thing on the Weekly Space Hangout where I'm the Kraken because I'm so skeptical. And if you don't like my Instagram page, I will destroy another Greek city. I will. I promise. I don't know if it's going to be Athens. I don't know if it's going to be Thessaloniki. I don't know. One of them is going down because if you don't like the Instagram. So just hang on. We'll be back in like 5-ish minutes. I'm going to leave it rolling, though, so you'll see the behind the scenes as we adjust the microphones and get everything set up. How do I do this? Can you guys see this? Hey, now you can see. Now you can see my notes. There we go. 5 minutes. So I'm gonna record show intro, so that there's this. Right. And then there's the special hour version, so I want to make sure this is. So intro, I'll say, and then instead of that outro, I'll say, hey, hang on, you know, this normal where I do the outro, but John's coming up. I see. Just those two 1-minute at the top and then bottom of the half hour. Yeah. To make the transition. Right. If we do it, yeah, we do it now. I'll just replace what you just did. And we are. Oh, we are. We're definitely doing it.
That is more news than I had. Also, before you get out of here today, I want a new promo from you.
Yeah, we'll do a new
Here's
program.
what we're going to do. I'm going to incorporate some So you talk about it. I'm Paul Sutter, blah, 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 and it's your opportunity to ask some questions. I'll dump that in. And then just All right. And let me, you ready for Johnny?
I'm always ready for Johnny. You guys cannot see that. That's ridiculous. Where Ho-ho.
Where do you want me?
Right there.
Okay.
Oh, can I have my phone because I need a new...
Yeah.
I'll use the timer on it.
So this is fun. I was watching.
You were...
Very
I
cool.
saw you interacting
Yeah.
with the worldwide... They're still on, by the way. We're live.
Oh, cool. We're
Yeah.
live.
Yeah.
Nice.
You smell like dog food.
I do.
Yeah.
It's because I ate a dog.
But that doesn't make sense. If dog is your food...
Caitlin Lynch suggested maybe moving that down there next time.
Okay, yeah, so it's blocked on the Facebook.
Right,
On
right.
the YouTube...
That's what she was referring to. Yeah, that's good there.
Yeah, so just tucking
Yeah.
it down so it's not...
Yeah.
Oh, does that show up
Yeah.
in the Facebook stream? I see. I think
All right. You're coming
Okay.
around to our way of thinking here. It's all right.
You have no way of thinking. Do you want headphones?
No, I just don't want to look stupid. I think I
Well-
need a haircut.
Good luck with that.
Ha
So I think...
Just a minute, I'll get a level check.
Okay, there's that one. Check. Can you guys hear Johnny?
gonna
Say
say-
something.
Check, check, check. 1, 2, 3. Check 1, 2, 3. Can you all hear me?
It'll be a while. They're delayed by like
Yeah.
20
Looks like.
seconds.
What is the delay?
Well, check this out. And this is so confusing. So this is live.
Mm-hmm.
This is the stream.
Okay.
The YouTube is usually like 20 seconds behind.
Okay.
And then Facebook is like 10 or 15 seconds.
Oh, so you got all going on at the same time.
It's all crazy, yeah. We're also going to Twitch. Twitch.tv.
Twitch? Oh,
yeah.
that's what you told me about that. I
Yeah.
gotta write that down. Is that what you're telling me about?
Yeah, it was. Twitch.tv.
Twitch.
I've got Johnny dialed in, so they should be hearing him.
I think so because here are the levels of out of the mix and
Can you hear him in your headphones? Because you remember you couldn't hear it. I think your
Check
name was Amber
one.
last time.
1, 2, 3. Can you hear me?
yeah,
Yeah?
I hear
good.
it.
Good.
All right. And Johnny.
Oh, someone says your hair looks nice.
Oh, who said that?
Kewalda Labette.
Thank you.
I hear you, Paul. Do you hear this guy?
Can you hear me? This is Johnny. Can you hear me?
And this is Paul out of my own microphone.
1, 2, 3. Check, check, check. 1, 2, 3. Testing. 1, 2, 3. Good.
Oh, Caitlin says we can hear you.
Okay, good.
We can hear you, Johnny. Johnny. Eating sugar. Are you familiar with that YouTube sensation? Do you have small kids?
Yeah,
Do
one.
Do they watch YouTubes?
Yes. My little one does. Yeah.
Have you encountered the eating sugar
No.
video? Okay.
What is that?
No, just
Okay.
Never mind.
Are you going to be looking at him when you're talking?
Yeah.
Yeah.
I think we're gonna chat.
Oops.
Jeez.
Do you want me to
Greg!
like cheat this way a little bit?
Maybe a little bit. Act like each other, you know.
TV space.
I
TV
thought I
Remember your live stream.
yeah. That's right.
Yeah, be careful.
Oh,
And we're gonna be family friendly.
what do you think I'm? I don't know what I'm doing.
I know exactly. You know exactly what you're doing. And
I
that's
know
the
we're not in
problem.
a nightclub.
Are you guys ready? Or?
You want me to record the new show welcome and outro?
Let's. Yeah, when you two are ready, I'll just fire it up, and then you do the new intro, the new outro, and then just go right into the show. So it'll be one big file.
We can
Okay.
hear Johnny great, and there's also a question that was on our Facebook, so you couldn't see it. But Joy wanted to know where is a good place in Ohio to watch the stars.
Right here on Facebook.
In WCBE Studio A. I gotta pull up a timer for our 2 segments, which are going to be 15 minutes and 11 minutes.
Okay. So you stick very closely to that so that it's easier to edit.
I pretend to be a professional.
Yeah, that's good.
I try and make Greg's life easy.
Yeah, that makes it easy.
I guess I don't need these. Just do whatever.
I'm saying that you do make my life easy.
Oh, thank you, Greg. He's so nice.
I know he's such a sweetheart.
But we are rolling. So.
Oh, we are rolling. Don't forget, Instagram. Go to Instagram, Paul Matt Sutter. Like the post where you see this picture, and you can win this. January 2nd is the deadline. You want it.
I want it.
Do you?
I want it. Yeah, I want any. Is it free?
Yes, it's free.
Absolutely.
Because I paid for it.
Please.
All right.
By all means.
So I'm going to record a new intro.
Okay.
Should I do the billboard or the intro different? Billboard. Okay. Live from Earth, it's Space Radio. This is Paul Sutter, and coming up, we are talking about Oumuamua, the intriguing interstellar interloper, and very special 1 hour edition here on New Year's Day. I've got Johnny DiLoretto here in Studio A to do a roundup of the best space news of 2017. And of course, taking listener questions about all things in the universe. We record every Thursday at 4 p.m. Eastern. Call 888-581-0708 to join the conversation. But first, the news. And a new outro. Now, this is the part where usually I would express my regrets that this broadcast is almost done, but it is not. We've got another half hour of space, wisdom, and juicy goodness because Johnny DiLoretto is here in the studio to join me for the next half hour to review and recap and possibly wisecrack at the best top space-themed news stories of 2017. This is a New Year's Day special here on WCBE. And we record every Thursday at 4 p.m. If this is your first time encountering the show, it is a real treat. You can call 888-581-0708 to join me on the air. You can also follow along on Facebook, YouTube, and Twitch. Go to spaceradioshow.com. And now it's time, after the break, to bring Johnny in and talk about space. All right. Good to go? Good to go?
Yeah.
Good to go? Yeah, you have no idea what's going on. Johnny DiLoretto.
Dr. Sutter.
The moment has arrived.
It has. I feel like I wasn't your first choice for this.
Because you weren't.
I figured. Why would you have me on to talk about,
Because I know you're a wisecracker, and you got a great radio voice,
Oh, thank you.
and you have fantastic hair.
Great.
Yeah.
Fantastic air.
And so it's like it was the three things I needed.
Okay.
And no, because I knew that you would add some color and some commentary
Well,
on this news.
Good. I'm proud to be here, excited to be here. This is a very elaborate setup you have
Isn't
here
it super
to pull this
complicated?
off. People from all over the world tuning in.
That is so
That's
exciting.
amazing.
Like, it's so cool for this show to connect Columbus to the world. I think it's just this really cool opportunity that we don't get a lot.
Right. And more people should know about it.
Absolutely.
Columbus is now global.
Columbus,
thanks to you.
I am leading the charge to make Columbus go from what was that? To
Local
Columbus. I
to
think
global.
I heard of that. I
Yeah,
think I heard of that.
right.
Columbus, that one
Exactly.
city. That one city. So I brought you on because we're going to talk about the top news stories.
Excellent.
Now, I made a
it
list.
appears as though I came prepared, but I assure you I
I
didn't
see
read
this
any.
stack of papers.
I didn't read any
You
of it.
didn't read a single
No,
thing.
I had every intention of doing it, and then
I'm
I
sure you
figured
did.
I can't learn all this. So let's
All
just.
this mumbo jumbo.
I'll have questions.
All right. Did you make your own list?
No, I printed off some of the things that
I
you
see,
told
I
me
see.
about.
All right. So I picked 6. Like usually it's like top 10 list or top 5, but I couldn't find 10
That you were interested in.
that I was interested in.
Okay, because I definitely found 10, but
But they were unrelated.
they weren't some of the things that you wanted to discuss.
Well, maybe we can get to one of your things later.
Okay,
No.
Yes.
Yes.
It's okay.
Okay, that's fine. Now, one of the most amazing things
Yeah,
is alien worlds.
I love this.
I love this. Like, the whole concept of exoplanets is blowing up. We have discovered how many planets do you think we know of outside the solar system? Pop quiz.
That would inhabit life, or just in general?
Any planet around any star that we know of, that we've measured, that we've detected.
I don't know. 10,000.
Not far off. We're like 5,000 or 6,000
Okay.
known exoplanets, planets outside the solar system.
Got it. Exoplanets.
That's the cool term for them. Exoplanets.
All right.
Like exoskeleton is
Yeah.
a skeleton outside. Exoplanet is planet outside the solar system.
Terrific.
Yeah. So exoplanet, we know of a few thousand.
Okay.
We're finding more every day. How many do you think are total in the Milky Way galaxy, our home galaxy, total planets in the Milky Way galaxy?
Oh man.
Do, 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 do.
493,864.
Way off. A trillion.
Okay. That was my next guess.
That was going to be a trillion.
That's a lot.
A trillion planets. Next question. I don't know. It's like, how many Earth-like planets around sun-like stars with the right orbit do we roughly estimate are in our own Milky Way galaxy?
I'm going to guess much less than a trillion.
Much less than a trillion.
Much less than 5,000?
Nope, blank face. Blank face here.
I would say that we know of
Not
like
that
a
we know
thousand-
of, that we estimate
that
are
we-
out there.
Oh,
That we estimate that are
in this galaxy.
in the Milky Way
In
galaxy.
the Milky
our
Way.
home.
Our cosmic address, so
Yes,
to speak.
Yes.
I'll say 1,000.
5 billion.
God.
See?
see? I'm just
It's
never good
crazy.
at numbers. It's terrible.
That's why we don't employ
Yeah.
you in astronomy. But check this out.
Yeah.
This year was the announcement of the TRAPPIST-1 system discovery.
I've heard of this.
TRAPPIST, there's also the beer.
Right.
Right.
And the monks.
And the monks. This is named after the monks and the beers.
Okay.
Yeah, because I don't know why.
You don't?
No, well, they just thought it'd be a cool name.
But
It
why?
stands for something like transiting.
Oh, it's
solar,
an
blah, blah, blah.
acronym.
It's an acronym.
Clever.
Capital TR.
Mm-hmm.
Anyway, this is a system. It's a star 40 light years away from the sun, which
Okay.
is pretty close in galactic terms.
All right.
Our galaxy is 100,000 light years across. So 40 is down the street.
Mm-hmm.
There are 7 planets orbiting this star. 7.
Yeah.
All of them small, rocky worlds, like Earth, like Venus, like
Yeah.
Mars. 3 of them are in what we call the habitable zone.
3 of those 7.
3 of those 7 are in what we
Correct.
call the habitable zone. Do you think? It's crazy. It was a brand new announcement. I think it's top news of this year. What are your first thoughts?
Well, my first thoughts are I so desperately want there to be life on those planets.
Yeah, that's
That
what
would be
everybody
so
wants. Yeah.
exciting. My imagination goes crazy thinking about what that might be, what that might look like. How advanced are they? Are they not advanced at all? Are they little amoebas? You know?
Yeah, amoebas. Hey, even
Weird
amoebas.
space amoebas.
Even space
What-
amoebas
what
would be
a-
so exciting.
Intelligent amoeba life be like? You know?
I think you need a bunch of amoebas together to make a brain to make intelligence. I think one amoeba
Okay.
is not enough.
You don't think?
I don't think.
That's
I was about to
presumptuous.
make a.
It's presumptuous of you. I mean, you don't know.
I mean, I don't know, but I'm just making a good guess. You
Okay.
need a bunch of stuff.
In short, I'm excited about the possibility of life on there. Aren't you?
Of course, that's what we're hunting for.
Okay.
That's why all these discoveries are so exciting.
So then I didn't want to get to this that quickly.
We'll get there.
But
Take us.
I
there.
brought up the other
Take us
day
there.
that there was this UFO sighted by a Navy pilot
You
off
did
the
not
coast.
just do this.
I did.
Okay,
Off the
fair
coast of San Diego.
Greg, can you edit this?
It was.
no,
was-
leave it in. Leave it in.
It was radar. It was tracked on radar, 2 different spots from the ship, and from the pilots.
Yep, they
thing.
got a little bloop.
Okay,
bloop.
and forget about all the speculation, right, as to what it was or
Yeah.
what it is. Apparently, according to this guy, it was moving like nothing he'd ever seen on Earth.
Okay.
And he's been flying around for a lot of
All right.
years. Now, let's just say that on this TRAPPIST system,
Mm-hmm.
there's some life out there, and it's capable of getting here. Maybe it was someone.
A Trappist monk.
It was a Trappist space monk.
A space monk.
Right. Now, so when you think about the possibility of life out there, do you personally just sort of preclude it being that advanced that it could reach us?
There is the question about. There is life out there in the universe. It's just a numbers game. There's too many planets. There's most likely intelligent life elsewhere in the galaxy. You play the numbers game. You know, it's really, really hard to predict, but you know, there's a lot of stuff going on out there. Intelligent life close to us? No, because we would have seen it by now. They would have had radio emissions. We would have spotted
Now,
it.
how do we know that they would have radio emissions? Maybe
Because
they have something else.
radio is super common. Radio is just electromagnetic radiation. So if and you said advanced. And to me, advanced means technologically advanced, which means you can generate radio waves.
Yeah, but that seems super specific. I think we couldn't even imagine what they might be using to communicate with us.
There isn't. One of the best things about physics is that the laws of physics are universal. Like they apply all across the cosmos.
Okay.
So not just so if we understand electromagnetic radiation, it means electromagnetic radiation is a thing across the entire universe. Nature generates radio waves. All right, there are physical processes in nature that generate radio waves.
Okay.
So as soon as you figure that out, you can say, "Oh, I can make my own radio
I see
waves.
what you're saying.
I can do it myself. Why
Okay.
not?" And so that's one thing. Something that close, incredibly unlikely. Interstellar travel is a whole other ballgame. Traveling from one star to another, the distances are so incredible, the energy's required, and there's like 0 point. There's no reason, if you're that sophisticated, why would you go to another boring star?
That would be awesome. What do you mean? Why? Wouldn't you?
Well, if you're that advanced, are you going to be asking the same kind of questions that we're asking now?
I don't know. I think you
And
are.
when you do a cost benefit analysis where you're like, man, that requires like our sum total energy of our entire civilization for 100,000 years to make that happen. Mm-hmm. So no, like there is just very, very little reason to believe in UFOs. If UFOs happen, that just means unidentified, right?
Right.
You don't know what it is. Now you can say maybe they just saw something they didn't recognize, but that's totally mundane. Versus interstellar civilization traveling in and coming to the Earth and doing whatever.
Yeah.
Without further evidence, which we don't have any further evidence.
Right. Somebody has some evidence.
Well, no, not even evidence. Like the evidence is what is in front of our plate.
Well,
like,
I mean, there's video.
no, all that, even including that.
Okay.
Taking the video at face value, including assuming it's not a hoax, it's not fabricated, which itself is a possibility, a strong possibility. Sure. Then you're left with the possibility of it's something mundane, but that we don't understand. Mm-hmm. Versus,
but even that's exciting.
Even that's kind of
I mean, not
exciting.
even mundane, but like if it's something on this planet, it's still exciting that it's this unrecognizable thing that can accelerate faster than a jet.
That can appear to accelerate faster than a jet.
Okay.
The data lie to us. Nature lies to us. Our senses lie to us.
Yeah.
All the time. That's why we have science.
It's still interesting.
Okay, fair enough.
People want to learn what it is.
I'm not personally interested.
That's
in that because
cool.
I think the universe.
I just only tied this back because we're talking about the possibility of life on the TRAPPIST,
which is what I think one of the top news stories. Now let's move on to another
let's
news
do
story. Is SpaceX and NASA. Mm-hmm. So two things happened. NASA crashed a spacecraft into Saturn on purpose.
Right.
This is the end.
It was done, right?
It was done. Just get rid of it,
Yeah.
guys. Thrown in the trash.
Exactly.
Get out of here.
It's kind of space
We'll get
littering.
a new one.
It really is kind of
totally
littering.
littered Saturn.
It's not cool, actually.
And this is a big spacecraft. It's the size of a bus. The Cassini spacecraft.
30 years from now, these guys are getting in trouble for doing that.
Yeah, we're gonna get some citation.
Yeah, it's just bad news. It's like it's just littering. Like,
yeah, but we did it for science.
Polluting the
We did it
oceans.
for science. It was worth it.
Okay.
Because we've never sent something into the atmosphere of Saturn before. Mm-hmm. And this was our only chance. And the Cassini spacecraft was on its last legs, running out of fuel. So we thought
Was this the Oleg Cassini spacecraft? Oleg Cassini, Italian designer. No,
sorry.
Little Italian design humor.
Okay, because I was going to do Cassini, the astronomer.
Oh,
the medieval astronomer, Renaissance astronomer.
I thought it was the guy that made these really cool sunglasses in the 70s, but apparently
Good
not.
to know.
Go ahead.
Maybe he was named after the astronomer.
Perhaps.
It was like a strong family
Probably.
lineage. Anyway, so they crashed it into Saturn for science, and it's like the end of an era, right? Because the Cassini was in orbit around Saturn for 13 years, 17 years. This is a huge mission lifespan.
Yeah.
We know so much about Saturn that we didn't know before, and it's over, and we don't have a replacement.
So they sent it crashing into the surface
atmosphere.
of the atmosphere. There is no surface, is there?
We think maybe deep down there is a rocky core to Saturn, but we're not 100% sure.
a rocky core.
A rocky core.
So what is this thing as they crash it into the atmosphere? What does it send back to us? What did we learn from the actual crashing portion of that journey?
We learned it was able to send back during its whole descent until it disintegrated. We learned about temperatures and pressures, wind speeds, magnetic field strengths, just the same kind of stuff we measure in the Earth's atmosphere to do like weather prediction. We are able to get those kind of measurements inside of Saturn itself. A little bit, just a little bit. But then on the opposite end of the spectrum is SpaceX, the rocket company, who sent a spacecraft, launched a rocket, brought it back to Earth, and then sent it back into space.
And that is significant, right? Because they're reusing. They're being environmentally conscious.
Right. They're also trying to make access to space super cheap. Because
Elon Musk probably wouldn't pollute space.
No, he's way. No, well, actually, he joked he wants to send his car, his own Tesla car, into orbit around Mars.
Oh,
because he can.
Just because
he can. And so that's technically also pollution.
Yeah.
Now we're polluting
Mars.
Unless,
unless, of course, he brings it back.
Good point. Good point.
Right?
I didn't
it's
think
only
of that.
pollution if you leave it there.
Yeah,
right?
yeah. If
you could throw a can.
No, yeah, that McDonald's bag.
Yeah.
I was going to come back for
Coming
it.
back for that. I'm placing it
in
there.
like 20 years. That's Elon Musk's plan.
Okay.
He's not going to pollute. He's not a polluter.
All right.
And so it's cool because that is a major milestone. The first time a rocket has been reused.
Really? Why? Is it just because they're so damaged usually that they're...
Well, usually we just chuck them. Like a rocket sends a little capsule up into space. The capsule goes into orbit. And then the rocket runs out of fuel and then just crashes in the ocean and we leave it there.
Huh.
And so that's
More
why...
pollution.
More pollution. That's why it's so expensive to send stuff into space.
Yeah.
Because we just trash the engines. We trash the engines. We trash the rockets every single time. Now that SpaceX has figured out how to bring the rocket back, it flies back automatically and lands.
Yeah.
And that makes access to space cheaper.
It landed on a ship, right?
Yeah. In some cases, it can land on a barge in the ocean. In some other cases, depending on the payload and all that, it can actually turn around and fly back to a base on land and land there.
Can you have it land on a specific person, for instance?
We could work that out. I'm sure that's in the long-term plans for Elon Musk. You
Elon
got a list.
Musk, yeah.
You got a list.
I do. I know who's at the top of it too, but that's interesting.
Yeah.
So now is this a cue that NASA is going to take from him? And...
NASA's just going to rent the rockets. In fact, NASA already had a mission using SpaceX using a reused rocket. So, which it's cheaper for NASA, it's cheaper for everybody. Good for them.
Yeah.
We've got to take a little break. I've got Johnny DiLoretto here in the studio on Space Radio. We're going to take a short break and get right back to the top space, astronomy, rocketry, universal stories of 2017.
Exciting.
Good stuff. Uh-oh. We're reporting we've got trolls in the chat.
Uh-oh.
Oh, man, there. Someone's yelling at Greg.
Why?
I don't know why. They just said, Greg. Greg. Not us. We're good.
Why?
I don't know. I think it's because he came in to adjust the mics.
Oh, I had to adjust the mics.
Greg had to adjust the mic, so be kind to him.
Johnny was popping his pee.
Oh, sorry.
All right.
And our second segment is going to be shorter, 11 minutes.
Cool.
But we just have colliding stars, the interstellar rock, and then the big eclipse, which I think is the top story.
Awesome.
You guys sound good.
Cool.
Well, we knew that we sounded good.
All right. So how long are the breaks?
Like just a minute. All right. Ready to go?
Yeah.
Welcome back, everyone, to Space Radio. I've got Johnny, the DiLoretto, here in studio to talk with me about the top space and astronomy news stories of 2017.
Yep.
Next up on the list, and this is no particular order, next up on the list is, let's talk about colliding neutron stars.
Let's.
Why not?
I don't know.
We have a cool name for them.
Okay.
Kilonova.
That is
a great name.
That is a badass.
Kilo
name.
1,000.
'Kay.
1,000 times stronger than a regular nova.
Kilonova.
If two neutron stars, which
Now,
are
if that doesn't become the title of a Michael Bay film within the next 5 years,
Kilonova,
I don't know what
starring
will.
who's going to be in it?
Mark Wahlberg,
Oh, good choice. Good choice.
Will Smith.
What's
Mark
the plot?
Wahlberg and Will Smith.
Are
How
you
about that?
Are you gonna?
They
give us
both play the respective stars.
neutron stars.
Yeah.
Yeah. And so what's the plot outline there?
Well, they're just on a collision course, and
With destiny.
one of them will not. They won't yield.
Yeah. And
And
they're gonna spiral in. Mm-hmm. And then they're
How do
gonna-
they approach each other? Will Smith and Mark Wahlberg.
Yeah, so these two neutron stars, which are like Hollywood stars, small, dense, but very bright, and they orbit each other, and that orbiting, that mixing up of space-time emits gravitational waves.
Okay.
And that bleeds energy out of the system, so they slowly spiral in towards each other, and then they collide, they explode, and then they merge together, and they produced a black hole. So there's now a remnant black hole. We saw, this is why this news result is so cool. We saw the gravitational waves themselves.
Yeah.
And then we sent out a worldwide alert saying, hey, everyone, we saw this gravitational waves. Does anyone else see this? We followed it up with normal telescopes, and we saw the actual explosion occurring.
Wow.
So we saw the same event with gravitational waves, which gave us a picture that we wouldn't be able to get otherwise. And we saw like the remnant explosion die off. And so we were able to paint this full picture of this event, this highly energetic, very rare event in our universe.
How long does this take to play out?
The collision itself lasted 2 minutes, I think. From the point where it started generating strong enough gravitational waves where we could detect it to the actual explosion was about 2 minutes, if I recall right.
Okay.
Yeah.
So that's interesting.
It was really big because it's a new deal. It's something we've never done before.
And what do we learn from it? What's the big takeaway?
The big takeaway is that it turns out, and we weren't too sure about this, but this pretty much confirmed it, that these kinds of collisions produce a good fraction of the heavy elements in our universe. So the gold in, say, a wedding ring here on Earth, a good chunk of it probably came from a neutron star merger long ago. The energies were enough to fuse higher elements. We didn't know that.
That's awesome.
That's super awesome,
Yeah.
right? And the people who developed the detector, the LIGO gravitational wave detector, who've been operating for decades, they won a Nobel Prize for their work this year.
Wow.
2 stories in one.
Neutron stars colliding.
Why
What do
not?
we call it?
A kilonova.
Kilonova.
A kilonova. Also,
If not
okay,
a
go
Michael
ahead.
Bay film, a rapper.
A rapper. Name one rapper.
Kilonova. No, I mean.
Oh,
that
that's
would-
the name.
Yeah. If it doesn't become a Michael Bay film,
Kilonova the rapper.
there should be a rapper out there that snags that real quick and
Kilonova.
comes Kilonova.
Don't do that.
Kilonova.
Just stop, please.
No, I'm doing
I'm
it.
so glad the radio
Doing
listeners
it because
cannot
now
see
there's
you.
going to be a record
There is right here on the camera.
that I invented it.
Go to youtube.com/Paul M. Sutter
Hmm.
to have your daily cringe. Now, and now we have, I talked about this in the first half hour, we have our interstellar visitor.
Yeah.
Oumuamua.
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 Wow.
Hawaiian word, roughly translates to scout.
Scout.
It's about the size of a skyscraper, tumbling through our solar system from who knows where.
End over end.
Yes, end over end. That was the surprising thing. It's we didn't expect an endo.
And it was sort of elongated. We haven't seen this
We
before.
haven't seen
An elongated, like, cylindrical.
cigar.
Yeah.
It's about
phallic,
the size of a skyscraper.
Like a phallus.
I mean,
like a
yes,
phallus.
skyscraper,
Yeah, okay.
cigar.
Right.
It's longer than it is wide, and
Okay.
it's tumbling, and it's obviously not from our solar system. Mm-hmm. And
And this is that's significant because stuff from other solar systems don't usually enter ours.
we're not sure. We're not sure how common this is. It could be maybe one object per year encounters our inner solar system.
Mm-hmm.
This is the first time we've spotted one. So we know this has definitely happened in the past. We just haven't had the capabilities to actually see it.
What was it made of?
Dirt and ice.
Exciting stuff.
That's about all we got. Well, that's like what everything in the universe is made out of.
It's kind of
Dirt
like the
and
new
ice.
Star Wars movie. It looks really awesome, and then you get there and it's just like dirt and
Dirt
ice.
and ice. Dirt and ice. Harsh, man.
No, that's me trolling these people.
Yeah, everybody.
Everybody's
The
gonna
listeners.
jump on that.
Yeah.
Okay.
I'm sure we'll get lots of go to Instagram.com/Paul Matt Sutter for the calendar giveaway. Now that you're interested, now that you're listening.
Yeah.
Yeah, no, that was actually it's Dirt and Ice, which is like what most small objects in the universe are made of.
Mm-hmm.
Asteroids are just more dirty than they are icy. Comets are more icy than they are dirty.
I got it.
And that's it. That's all we got.
And we tried to talk to it, right?
Oh my gosh.
Didn't we?
Yes, we did, but how dumb was that? It's just a rock. No, the breakthrough list and say, hey, maybe it's a spaceship and it's beaming signals at us. I'm like, come on, guys, we're trying to be respectable.
Leave
here.
no stone unturned. That's what these people were thinking. It's from another galaxy. Got to take a shot. Right?
But it's obviously a rock. It is not. Just don't waste time. We could have taken that money and that telescope time and done something productive with it.
What? What would you have done?
Figure out what kind of dirt and ice is made out of.
How would you do that? Send somebody up there? Send a thing
That's
up there?
That's what we wish we could have done. Is actually get a sample or retrieve it. All we have is remote sensing, remote observing with our telescopes. We can do what's called spectroscopy. We can figure out the elements that are on the surface. So we know that there's carbon, there's hydrogen on the surface. There's water ices on the surface. And that's about it. It's too far away already to pick up anything else.
Huh.
That's
Okay.
it. But that was so super cool.
So it was really exciting, and then it was kind of like, it's
yeah.
just,
So like Star Wars.
yeah.
Yeah, there's lots of building.
Yeah,
Like,
you're right.
it happened.
The
It
best
happened.
moment is like right when the lights go down and the score
Lucas-
comes up and
Yeah.
a long time ago in a galaxy, and then
you're
it's
like,
all downhill from
it's
there.
already past the orbit of Mars.
Got it.
Now the number one story that I think there was a lot of hype for.
Yeah.
A lot of build up, a lot of excitement, and it paid off.
Right.
The total solar eclipse, the Great American Eclipse. Where were you on August 21st?
I was actually in Kent, Ohio,
Nice.
and I was in a parking lot
Okay.
waiting for my significant other to come out of class. Mm-hmm. And as soon as she did, we checked it out. We were outside.
Did you wear your safety glasses?
I did. I borrowed them, actually. There were some people around.
You gave them back?
with cereal boxes with holes in it.
Yeah,
and
the
all
little
of that,
projectors
and the
yeah,
glasses,
yeah.
and
Here's the thing with the eclipse. No, it's okay. It's okay.
No, I was
A partial eclipse, kind of boring.
yeah.
You heard it from me. I'm an astrophysicist. I'm an advocate of science. I love communicating science, sharing the wonder of the universe that we live in.
Yep.
Partial eclipses are kind of boring.
Yeah.
You put on your glasses, you're like, oh, that's cute. And then you're done.
Right.
The big thing is to be in totality.
Yeah.
Total solar eclipses are the difference between 99% eclipse and 100% eclipse is not 1%. It is like almost literally the difference between night and day.
Yeah.
It is ridiculous. So I was down in Nashville
Yeah.
on the path of totality, the biggest city on the path of totality. Didn't see totality.
Really?
It clouded up.
Oh,
Clouded
man.
up. We got to 95%. Then a big old cloud came in, blocked our view. Now it got super dark. We could see stars
Yeah.
in the middle of the afternoon. Crickets and birds started chirping because they thought it was nighttime.
Right.
Didn't see totality. One little cloud blocked the sun. And so I missed it. And then 5 minutes later, it drifted away.
But significant numbers of people did across the country see.
yeah, this great
This-
American eclipse, hundreds of millions of people, where the entire nation, continental United States, sorry, Alaska and Hawaii, saw at least partial eclipse, something
Yeah.
like at least 65%. And then so many people, I think it was like the most traveled event in human history. Some people were claiming that. I don't know if that's true, but that sounds great. And they collected themselves along that 60-mile wide strip across the United States
Right.
from Oregon coast to the South Carolina coast and enjoyed this spectacular event.
People were really, what was not having experienced the totality and having a sort of
Right.
underwhelming experience.
Wah, wah.
What was really cool, though, is to hear all these experiences and how moved people were by it and inspired by it. That was
People were in
exciting.
tears.
Yeah.
And I don't blame them because you get goosebumps. You get literal chills because it cooled down because the sun is blocked. And it's just this incredible natural phenomenon that most people never experience. And even if you do, it's maybe once in your entire life.
Yeah.
The next one isn't until July of 2019. And that's in South America, down in Chile and Argentina.
Right, that's what I wanted to ask you. Do I have time to ask you a question?
We've got 60 seconds.
Okay, real quick. This happens all over the world.
Once
right? Like-
every 2 or 3 years or so.
okay, so it's not quite as rare a phenomenon as it
But most of the
seems.
time, it happens over open ocean. Most of the time, it happens in inaccessible parts of the world. It's very, very rare for it to happen where it's easy to see.
Cool.
So it is rare.
Yeah.
It is a very rare thing. It's a very special thing, and I think that was the top thing to happen.
And I have a
this year.
feeling like my appearance on this show is equally rare.
Yeah, so see
So
you in a couple years.
Yeah.
See you in a couple
I'm
years.
very
You're
excited
the
to have been
moon.
here, though.
You have blocked my light for a few minutes.
However briefly, it was great.
But thank you so much for joining me today to go over these stories. It was
Thank
fun
you.
to chat with you. That's
Always.
Johnny. Where can people find you?
They can find me here at WCBE 90.5 FM. I'm the community relations guy here. Donate to public radio. We depend on you for our survival.
That's for sure.
And also, you can hear me on Cinema Classics Thursday nights at 8:01 p.m. or at WCBE.org. And you can also see me at the Not So Late Show once a month, every last Thursday of the month at Shadowbox Live.
Very cool. Thanks again for joining me.
Thank you.
Ta-da!
Fun, 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 till Daddy takes the T-Bird away.
Since I get this saved, how about a promo with you too?
Okay, we'll do a promo. And live streamers, what should I name the show? I'll let them choose the title.
Cool.
Which is sometimes a bad idea.
Yeah, I have a feeling like that could be disastrous.
Someone asked, was Johnny a reporter for Channel 6?
Yeah.
Yeah.
Yes, I was. 6 and 28.
Well, people are arguing.
What are they arguing about?
I have no idea. My head was turned so I couldn't follow along.
Yeah, how do you do that normally? Does it bring
Well,
you in and out
What do
of
you
the
mean?
show? Like, if you're having do you normally have a guest?
I don't normally have a guest.
You
but
just
I
take
usually
calls
I
and-
take calls and
And so that is the primary focus. What's going on there,
Yeah.
right?
I was waiting for it to say.
dark matter and gunk rocks. I like that. Jonathan H. Dark matter and gunk rocks.
The search for the first star.
Because that was the top half.
Yeah.
The top half. Any other suggestions? More than welcome. Don't be shy, folks. It is challenging to balance like spontaneous answer to a question.
Mm-hmm.
Read the news, keep an eye on the timer, see the chat, see if anything interesting pops up.
Yeah.
But that's what makes it fun.
Well, I'm glad I get to see how you really do all of this. So you have screen, the mics, the light,
Cameras.
this iPad. What
iPad.
is this? Just to hold your papers.
This is to hold the paper. That's the stand for the iPad. And the iPad I just use for timers for each of the segments.
Oh, cool.
Just to keep
That's
track.
it.
That's
All right,
it.
So you can. Nice.
Oh, I see. Someone started a Humans Are Destroyers theme. Kilobossanova. Ooh, that's not a bad name, Gareth.
Kilobossanova.
Kilobossanova. I like that.
Mm-hmm.
I just might make that the title. Sorry, Jonathan H. I like Kilobossanova
As the show title.
as the show title.
It's great.
That is, I like it. Rolls up. What do you think, Greg? Kilobossanova? You like it? All right, I'm closing the show down.
Okay.
That is it. That is enough of these shenanigans. Thank you so much, everyone. Don't forget to go to Instagram.com/Paul M. Sutter. No, Instagram.com/Paul Matt Sutter for the giveaway. It's awesome.
Do you autograph those? You should autograph them.
I'll autograph it. That will lower its value.
For now.
I'll autograph it.
But in the long run-
in like 50 years.
In the long run,
See you, everyone.
skyrockets.